talk about determinants before we talk about inverses. So we're going to section 7.7. So determinant of a square matrix. I want to emphasize, so I'll rewrite it. Determinants are only defined for square matrices. So what we're doing today only applies to square matrices. So what we're going to do is talk about the procedure for finding the determinant of a 2 by 2 matrix, which is really easy. And after that, the process for finding determinants of any larger matrix, 3 by 3, 4 by 4, come down to finding determinants of 2 by 2 matrices over and over again. So for a 2 by 2 matrix only, so this process that we're talking about now only works for a 2 by 2 matrix. We write A is, I'm going to say it's a matrix A, B, C, D. The symbols that we use apply to larger matrices. It's the procedure that only applies for 2 by 2. The determinant of A. And we write either DET A, DET for determinant. We also write with straight bars, like an absolute value. This means determinant of A. You'll also see it written like this, with the elements of the matrices, or the matrix, inside the straight bars. To calculate the determinant of a 2 by 2 matrix, multiply A times D and subtract B times C. So multiply the two numbers on this diagonal, multiply the two numbers on the opposite diagonal, and subtract them. This subtraction is an easy one to forget. Often students want to add. We subtract. So for example, if our matrix is -6, 2, 7, 1, the determinant of A, which is the same as this, which is the same as this, is -6 times 1 minus 2 times 7. So this is -6 minus 14, which is -20. Mm-hmm. It's we can kind of sort of think about it as like the absolute value of a matrix, but it's just the straight bars mean determinant when we're talking about matrices.
Okay.
Yeah.
So like, what is a determinant?
It doesn't represent any kind of like physical thing about the matrix.
Okay.
It's just this quantity that we calculate.
Okay.
We use the determinant to help us figure out other things.
Okay.
So we'll use the determinant to help us figure out and inverse. We can use a determinant to decide if a system of equations has a solution. We use it for various other things, but for now it's just a number.
Okay. Thank you.
All right, so finding the determinant of a 3 by 3 matrix really comes down to finding the determinant of 3 2 by 2 matrices. So what I want to do for a 3 by 3 matrix is go through an example. I could explain the process, but it's easier to see with an example. But it comes down to calculating the determinant of a 2 by 2 matrix. So, and what we're going to do, we'll need to be able to calculate 3 by 3 determinants by hand. We'll use them again when we talk about three-dimensional vectors. We'll do something that we call a cross product, and we can visualize as a determinant. Anything above a 3 by 3 matrix, we'll use a calculator, and I'll show you in a little bit how we use our calculator. So let's find the determinant. If A is this 3 by 3 matrix, and I'm going to write this 3 times. I'm doing this just for this first example because it's easier to visualize what we're doing. If I write the matrix 3 times, you don't always have to write it 3 times. I'll show an example after this one. All right, so the determinant of A equals. The first thing we need is to put some signs with this. So I'm going to label this a plus, a minus, and a plus. That plus, minus, plus across the first row, that's always how we do it. Doesn't matter what the numbers are, that's always how we find a determinant. You came at a rare moment. They're being quiet. All right, so what I'm going to do is the first step. I'm going to take this number 2 with the plus sign. So this is plus, whatever that is. And then I'm going to cross out this row and that column. First row, first column. And I'm going to multiply this by the determinant of the 2 by 2 matrix that's left when I cross out that row and that column. So I have a little 2 by 2 matrix left when I cross out that row and that column. We're going to find the determinant of that 2 by 2 matrix. Now I'm going to take this minus sign. Minus. Now I'm going to take this number and cross out the first row and the second column. And now I have a 2 by 2 matrix left after I cross those out, and I'm going to find the determinant of that. And then I'm going to, for the last step, I'm going to take the plus, and I'm going to take this number, and I'm going to cross out the first row and the third column, and find the determinant of that 2 by 2 matrix that's left. So then we just do all this arithmetic. So this is 2 times -9 minus -4. So -9 plus 4 is -5. Minus -1, so I get plus 24 minus 2. 8 times 3 minus 2 times 1. 22. And then I get a plus 5 times 16 minus -3. Whoops, this should be a negative 2. Negative 16 minus negative 3, so negative 16 plus 3, negative 13. And then I do this arithmetic. Negative 10 plus 22 minus 65, and I get negative 53. So, couple of things. It's very easy to forget this minus sign here. So it always goes plus, minus, plus. And it's very easy to do what I did here and lose the negative sign. So it's easy to make a sign error. Yes?
Will there ever be one like on the homework where it's like not plus minus plus and then it would be
No,
like not possible?
it's always plus, minus, plus.
Always.
We always do it plus, minus, plus. That's just, again, how we're defining the process of finding a determinant. Yeah.
Do you change it to be plus minus plus, or will the given matrix vary?
It doesn't matter what the matrix is like, it's always plus, minus, plus. It doesn't have to do with the signs of the numbers here. It's just the signs that we put. I'm going to put a plus there. That's a minus. It has to do with the signs we put in front of these. Okay? All right, so the process of finding a 3 by 3 determinant involves finding 3 2 by 2 determinants. If we go to a 4 by 4 matrix, what we do the same process. 4 by 4, it would be plus, minus, plus, minus. We would cross out the first row in the first column and find the determinant of that 3 by 3 matrix. Well, finding the determinant of that 3 by 3 matrix involves crossing out rows and columns and finding 3 2 by 2 determinants. And we have to do that 4 times. So the process gets really big. So that's why after a 3 by 3 we use a calculator. Yeah.
A would equal 53.
The determinant of A.
Oh, so that's not like the absolute.
Absolute value. No, this is for in matrices. That means determinant.
I'm sorry.
All right. So let me do another example, and I will show you how you probably are going to go about this when you actually do it in practice. So I'm just making up some numbers to put in my matrix. All right, so there's my matrix. Let's stop talking, please, folks. The determinant of A. The way that I usually do this is just visualize that process in my head. This is still plus, minus, plus. We always do plus, minus, plus. So I'm going to do 1 times, and then I just visualize crossing out that row and column and do the 2 by 2 determinant in my head. So this is going to be 2 minus 4. So negative 2. Minus, from this negative sign, 2 times, and I visualize crossing out that row and that column, negative 4 minus negative 12, so negative 4 plus 12, 8. And then plus, from this, negative 3, that's for this number. And then I visualize crossing out that row and that column, 2 minus 3, negative 1. So we get a negative 2 minus 16, so negative 18 plus 3, negative 15. So the determinant of this matrix is negative 15. And when I do determinants, I usually write this out to make sure I'm not making an error with my pluses and minuses, because it's very easy to do. this negative is where most students make mistakes with determinants. All right, questions? So let's take a look at our calculator. Determinants are one place where we think, thank goodness, computers exist. Because it gets very computationally intense after a 3x3. All right, I'm going to clear out the matrices that I have from yesterday. I'm just deleting the matrices that I have from yesterday. I'll show you at the end when I put more in. All right, so what I'm going to do, I need to edit my matrix. So go to Edit. I'm going to edit matrix A. I'm going to make it 3x3. And let me go back here, and let's do this matrix so we can check our work. To enter, -1. So I'm doing this matrix. All right, so there's my matrix. That's the first example we did. Now I'm going to exit out of here. And now we're going to go to our matrix menu, and we're going to go over to Math. The first one, DET, is a determinant. Hit Enter. And I'm going to put matrix A in there. So go back to the matrix menu. Matrix A. Hit Enter. And I get -53. And that's exactly what we came up with there. The only downside with the calculator is I think it takes about as much time to enter the numbers as it actually does to calculate a 3x3 determinant.
But the thing is, calculator, no, it's correct.
In the other class, I put a +1 in there by mistake, and the answer was completely different. So changing one sign changes your answer. So let's look at that again. Let's do the second example. Second matrix, I'll make this matrix B. Whoops. I need to edit matrix B. All right, so we're going to make it a 3x3. This your calculator do 3x3, 4x4, 5x5, 10x10. You just have to put all the numbers in. So there's my matrix. Quit out of there. Find the determinant. Go over to Math. Determinant of matrix B. And I get -15. All right. So on the test, on the Chapter 7 test, there will be a no calculator portion and a calculator portion. On the calculator portion, you might be asked to find the determinant of a 5x5 matrix. So hopefully that would be those would be on a calculator. So hopefully that would be gimme points. All right, questions? Let me show you how to get rid of matrices. If you have a bunch of matrices, you want to get rid of them. You go to second, here this memory, which is above the plus sign. And we're going to do memory management delete, so number 2. And we go down to matrix, so number 5. And it'll have all the matrices that you have stored. And you're going to hit delete. Delete matrix A, delete matrix B, and now they're gone. All right, questions on finding determinants? Okay. You barely missed any.